The title of today's lesson is Using Objects to Divide. The objective is I will use place value to understand the algorithm of long division. So today we're going to be talking about place value blocks and using them to understand what you are doing when you're doing the algorithm for long division. The following problem says Paulo has 39 patches from states that he and his relatives have visited. He wants to pin them onto a board. Paulo wants to arrange the patches on the board in 3 rows. How many patches will be in each row? So if we look at the problem and use cubes, we're first going to circle the numbers that are keys. So we have 39, and 3. Then we're going to underline the question, which says how many patches will be in each row. Then I'm going to box keywords. So each is a keyword, and if I'm going to arrange them, then it's going to be division, because each is for multiplication or division, but since I'm arranging them onto a board into groups, then that means that it's going to be division. So then how would we model 39 with place value blocks? So if I was to model 39, I would first use 3 10 blocks, 10 rods, because each one of these are with 10, so 10, 20, 30. And then I would use 9 1 blocks. Well, in this case, I'm going to use X's. So that's 3, 6, 9. If I was to arrange them in 3 equal rows, if I had 3, since I have 3 10 rods, then I can put a 10 rod in each row. And then if I have 9 ones, well, that means I can put 3 in each row, and I have nothing left over. So my answer was, how many patches will be in each row? Well, the answer would be 13 based off of my picture. Okay, if I was to do long division, remember it's divide, multiply, subtract, check, bring down. So my problem is 39 divided by 3. So what we did with the picture is we looked at the tens. There are 3 tens. Do I have enough tens to put them into 3 groups? I do. I could put 1 10 into each group. That's my division. Now I'm going to multiply 1 times 3, which is 3. Then I'm going to subtract. 3 minus 3 is 0. I'm going to check. Is 0 smaller than 3? It is. So I checked. Then I'm going to bring down. This is where bring down comes into place. I haven't divided out my 9 ones, so I'm going to bring those 9 ones down. If I'm going to have 9 ones and I'm dividing them into 3 groups, how many would be in each group? I would have 3. There's my division. Then I'm going to multiply. 3 times 3 is 9. Subtract is 0. 0 is smaller than 3. I have nothing left to bring down, and I do not have a remainder, so my answer is 13, which matches my picture. Here's another problem. Helen has 55 postcards. As an art project, she plans to glue 4 postcards onto sheets of colored paper. How many pieces of paper can she fill? So if I use cubes, the key numbers are 55 and 4. My question says, how many pieces of paper can she fill? And box keywords. Well, there isn't really any keywords that stand out, but since you're putting a certain number onto each group sheet of paper, then it's going to be division. Now we're going to solve. So if I look at my problem, I have 55. So that means that I have 5 tens that I want to put into 4 postcards. So here, these circles are representing my 4 postcards. Well, in this case, I only have 4 tens to use, which means I have 1 10 left over. I know that this 1 10 actually equals 10 ones. So now I have the 10 ones that are left over from the 10 rod that I didn't use. 10 ones that are left over from the 10 round that I didn't use, plus the 5 here. So that means I have 15 ones to use. So if I continue to put them onto 4 postcards, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, well, there's not enough to put in each one, so I need to take those last 3 out, which means that I used 12 of my ones, which means I have 1, 2, 3, because that's 13, 14, 15. I have 15 altogether, but I have 3 that are left over. So if I was putting the postcards onto each colored sheet of paper, in each sheet there would be 13 postcards, but I would also have 3 left over, so I would have a remainder of 3. So if I was to do this problem using the standard algorithm, divide, multiply, subtract, check, bring down, I would start with my problem, which was 55 divided by 4. So again, when I had 5 tens, and I was putting them into 4 groups. Well, I only was able to put 1 10 in each group. That's my division. Then I multiplied 1 times 4, which then told me I had 1 10 left over. Check, is this number smaller than my divisor, which is 4? It is. Now I'm going to bring down the 5 ones that I have not divided out yet. So now I have 15 ones. So I had 15 ones divided into those 4 groups of paper. When I figured that out, I was able to put 3 ones on each paper. So then I multiplied 3 times 4 is 12. I subtract 15 minus 12 is 3. When I check, 3 is smaller than 4. So I'm good there. So here is my remainder 3. So this matches my picture of 13 remainder 3. So we're going to do this problem. Now obviously it's not going to be in our whiteboards. We're going to put it in our notes. So I have 76 magazines and I'm putting them into 5 boxes. So I could draw a picture. So I could have 5 boxes, 3, 4, 5, and I could look at my number and say, well, there's 7 tens. So how many tens can I put in each box? Well, I could put 1, 2, 3, 4, 5, and then I would have 2 tens left over, which means I would actually have 21s plus 6. Then that means I have 26 ones to put in each box. So I could count by saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and I have 1 left over because I used up 25, so I have 1 left over. So with a remainder 1. So my answer would be, how many magazines are going to go in each box? Well, there's 1 10 and 5 ones. So 1 10, 5 ones. And then I have a remainder of 1. Now if I do it the algorithm way, I have 76 divided by 5. So I look here at my tens. So if I have 5 boxes and 7 tens, that means I can put 1 10 in each box. I then multiply. 1 times 5 is 5. Then subtract. 7 minus 5 is 2. Check. Is 2 smaller than 5? It is. Then I bring down the 6 ones that I have not divided out yet. So now I'm at 26 ones to divide between 5 boxes. Well, I know that I can put 5 in each box because 5 times 5 is 25. I subtract. I get 1. Is 1 smaller than 5? It is. There's nothing left to bring down, so I have a remainder 1. Both of these answers match. Let's try one more problem. So I have 56 marbles with 3 bags. So here are my 3 bags. I'm first going to look at my 10. So I have 5 10s to put in each bag. So I have 1 10, 2 10s, 3 10s. I don't have enough 10s to put one more in each bag. So I used 3, which means I have 2 left over, plus my 6 that ones I haven't used. So now I have 26 ones to put into the bag. So I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I used 24, I have 26. I don't have enough to put in each one, so I'm going to subtract, which means I have 2 left over. 2 ones left over. If I count, I'm going to have 1 10 in each bag, and I'm going to have 8 ones in each bag with a remainder 2. Now, if I do it the long algorithm way, I have 56 marbles divided into 3 bags. So first I'm going to look at my 10s. If I'm putting them into 3 groups, how many 10s can I put into 3 groups? I can put 1 10, that's divide. Now I'm going to multiply. 1 times 3 is 3. Then I'm going to subtract. 5 minus 3 is 2. Check. This number is smaller than my divisor, so I'm good. Now I'm going to bring down the number that I have not divided out yet, which is 6 ones. Now I'm left with 26 ones to divide up in 3 groups. Well, if I figured it out with a picture, but if you count, how many times can you count by 3 before you get to 26? Well, 8 times, because 8 times 3 is 24. I'm going to subtract. 26 minus 24 is 2. There's nothing to bring down, so this is my remainder, 18 remainder 2. Again, these 2 answers match.